Hello students, in our previous videos we have seen what is group, what are all the properties of the groups and all those details in our previous videos. In this video we are going to learn definition of what is semigroup and what is monoid. These questions you can find it in your 2 marks because sometimes in question papers they are simply asking define monoid, define semigroup. We are going to see those two definitions here. First, let me write the definition. Simple. You can see the word semigroup. Group satisfies 4 conditions. Then it satisfies half of 4, 2 conditions. Simple. Let G be a non-empty set. Associated with a binary operator star, and we will represent this like that, right? That is G comma star is said to be a semigroup if it satisfies following conditions. We can say 2 conditions. Number 1, closure property. That is, this set G must be closed with respect to this binary operator star. You know very well what is the closure property. For all A comma B belonging to G, we must have A star B belonging to G. Second one, it should satisfy associative property. What is the associative property? We have already seen it. For all A comma B comma C belonging to G, we must have A star B star C is equal to A star B star C. Any non-empty set satisfying these 2 properties is called a semigroup. Let me give you an example. Let us consider example. Consider set of all natural numbers along with the binary operator plus. You can see that what is natural numbers? It starts with 1, right? You consider any 2 elements. For example, 2 plus 3. It is 5. It is inside here. Any 2 elements you consider 2 natural numbers. You add them. Again you are going to get one more natural number, right? So it is closed with respect to n. Similarly, it satisfies associative property also. How? You consider any 3 elements. 2, 10, there are some 25. You add these 2 first. It will be 12 plus 25, 37. Same here. 2 plus 10 plus 25. 2 plus 35. It satisfies both the conditions. So it is the set of all natural numbers along with the binary operator addition is a semigroup. Now we are going to see monoid. Same definition. Let G be a non-empty set associated with the binary operator star is said to be a monoid if it satisfies following condition. First condition, closure property, yes. Second condition, associative property, yes. Along with that, it must satisfy identity property. The existence of identity. Third condition, What is that? There exists an element, special element we can say, an element E belonging to G such that A star E equal to E star A equal to A for all A belonging to G. Just identity property. If any non-empty set along with the binary operator star satisfying these three conditions, we will say that as a monoid. Okay, let us see an example. Consider set of all whole numbers along with the binary operator star. What is the whole numbers? Starts with 0, right? You can notice that in previous set of all natural numbers, we didn't have 0. It has no identity element. It satisfies only two conditions. It does not satisfy identity property. But here, it has identity element. Along with those two elements, you have 0, right? 0 plus any number plus 0 is again the same number. So it is a beautiful example of monoid. Here you can notice that we don't have inverse, additive inverse. What is additive inverse of 1? Minus 1. That minus 1 is not here. Additive inverse of 2, minus 2 is not here. So it satisfies only three conditions. It is a monoid. It is not a group. If you want an example of group, you have to consider set of all integers along with the binary operator. What we have seen in our first video, I have explained you. It satisfies all the 5 conditions. Closure, associative, identity, inverse and abelian, and a commutative property. Thank you.